Alright, hello everyone. Today we're going to be looking at intermolecular forces. Okay, there's three forces that you need to be familiar with. You have dispersion forces, dipole-dipole interactions, and hydrogen bonding. So we'll go through them each individually. Okay, let's start with dispersion forces. So dispersion forces are the weakest form of intermolecular force, and they occur in all molecules, and that's because of temporary fluctuations in electron distribution. So for example, if we look at this molecule here, this is actually pentane. There will be electrons within each of these bonds. There will be electrons, and sometimes as the electrons orbit the molecule, or they go around the molecule, there might be a higher density of electrons in certain areas. For example, there might be more electrons in this section compared to this section over here. And that will create what is called a temporary dipole. If there's more electrons here, then that will be negative, and then it will create a temporary dipole where this side will also be positive. And because of that, it will create a chance for this molecule to bond with other molecules. Because if we have two of these pentane molecules and they both have a temporary dipole where there's a negative and a positive end, then they can actually attract each other. Negative attracts positive. Okay. Now, these are the weakest because they're only temporary. So they're not permanent dipoles. Okay. But one thing to note with these ones is the longer the molecule, the stronger the dispersion forces. For example, if we had a 6 carbon chain instead of 3 here, then that would create, would have greater dispersion forces just because there's more electrons orbiting the molecule, which means there's a higher chance for those temporary dipoles to occur. So that's dispersion forces. They're the weakest. Now, we've also got dipole-dipole interactions. So this is when there's a permanent positive and a permanent negative end of a molecule. So we can look at HCl here. All right. So with the electrons, chlorine is more electronegative than hydrogen, which means that chlorine is going to pull the electrons more to the chlorine side. Because there's more electrons closer to chlorine, it has a more negative charge. And if there's more electrons near chlorine, it creates a more positive side for the hydrogen. So the hydrogen will always be positive or have a positive dipole, and the chlorine will always have a negative dipole. And because of that, you'll get two hydrochloride molecules. They will interact with each other because they'll always have a positive and negative end, and positive and negative attract. So that's an example of a dipole-dipole interaction. Okay, and they're stronger than dispersion forces. Now, if we look at hydrogen bonding, it's very similar to dipole-dipole interactions, but it occurs when hydrogen is bonded to a highly electronegative atom, such as nitrogen, oxygen, or fluorine. Like for this one, we can see that there are two water molecules, H2O, but because oxygen has such a higher electronegativity than hydrogen, it's going to pull those electrons even closer towards the oxygen side, which means that this area is going to be even more negative compared to the hydrogen. So that means that the interactions between two water molecules will be stronger because the hydrogen end is more positive and the oxygen end is more negative. So they're the strongest form of intermolecular forces. Okay, now let's talk about how this affects the physical properties. All right, so we're going to talk about boiling point and melting point first. Now, boiling point and melting point, they will increase when the intermolecular forces between the molecules are stronger. And that makes sense if you think about it, because if we have only dispersion forces, so if we let's have a look at ethane, there's only dispersion forces occurring in this molecule, which means that if we have multiple versions of these molecules, they're not going to be held together very tightly because, remember, it only has those temporary dipoles and they're not very strong. So it's easier to pull those molecules apart and boil or melt those molecules. But if we have a look at water, which has a significantly higher melting point and boiling point, because it has those hydrogen bonds. And those hydrogen bonds are very strong because there is a negative and positive dipole, and these interactions between the H2O molecules is a lot stronger. So this interaction is a greater force, which means it's harder to separate those molecules apart and turn them into a gas and liquid. Okay. Now, vapor pressure is a little bit different. So vapor pressure, that increases when there is a low force between the molecules. Okay, so it's inversely related to intermolecular force strength. Substances with weak forces have high vapor pressure because the molecules are not held together very tightly and they can easily escape into the gas phase. Now, solubility is very different. Solubility depends on whether the substances that are being dissolved, whether they have the same polarity. For example, if you have two non-polar molecules, then they will dissolve easily in one another. But if you have two polar molecules, then they will dissolve easily as well. But if you have a polar and a non-polar molecule, then they're not going to dissolve together very easily. So that's what this like dissolves like. That's what that means. So polar substances which experience dipole-dipole interactions or hydrogen bonding, they tend to dissolve in polar solvents, while non-polar substances which have dispersion forces dissolve in non-polar solvents. Okay, so hopefully that makes a bit more sense.